Hello everyone. All of you must have heard that Linux is an alternative operating system that you can use instead of Microsoft Windows, Apple macOS or Google Chrome OS. But once you search for Linux online, you find that the situation is much more complicated than that. There simply isn't a thing called Linux for you to download and put on your computer. Actually, guys, Linux isn't a product. It's an entire ecosystem of freely shared softwares distributed in many different ways. This software now powers most of the world's servers, supercomputers, and phones. That being said, I welcome all of you guys to this series of Linux sessions by Intellipaat, where we are going to delve into the intricacies of this software framework. For this particular session, we'll try to get ourselves introduced with the Linux framework. Then we'll talk about basics of shell and we'll also discover top shells in Linux. And at the end, we'll also cover the basics of kernel and what it is. But before we do that, make sure you hit that subscribe button and bell icon so that you never miss any update from Intellipaat YouTube team.
Hey guys, welcome to this Linux course. So first let's get started with which is introduction to Linux. So first, Linux is a Unix-like operating system developed by Linus Torvalds and thousands of open source contributors. So what does Unix-like operating system mean? So there was this Unix operating system even before Linux was existing. After that, Linus Torvalds came up with an idea of creating an open source distribution of Unix, which is now called as Linux. But right now Linux is more popular than Unix, but the base of any Linux operating system is Unix because it follows the same architecture of shell and kernel and other applications. So now Linus Torvalds is the main contributor for this large open source project Linux, but there are other contributors as well. Linus Torvalds started off this project, but later on, as this is an open source project, anyone could contribute to it. So like that, there were 11,413 different changes by individual contributors. So this was after version 2.6. Before that, still there were a lot of contributions. After that, there were again a large number of contributions, even from companies like Red Hat. Red Hat is one of the most popular Linux distribution company. So Linux operating system distribution company. They have both community versions and they have paid versions. So Intel is there, Novell is there, IBM is there. There are a lot of companies and they have all made contributions to the kernel. Moving on. So Linux is an operating system. It is reliable and secure than other operating systems. Also, it is completely open source. This basically means you can take the basic Linux operating system structure and create your own operating system using that. So it was launched by Linus Torvalds in the year 1991 on 17th September. So it is reliable and secure than others. This comparison we'll do right now because right now I am using an Windows operating system to show you this particular presentation. So the most common usage of any operating system is obviously Windows because it comes inbuilt in a lot of laptops, a lot of PCs and a lot of CPUs because Windows is the most popular, the most easier operating system, and also it has a name for it for personal computers because you can play a lot of games in that. Linux is not that much compatible with games. But coming to the IT sector, coming to the development part, Linux is preferred than Windows. So one more reason for learning Linux is everywhere. So any operating system you take will have some kind of a Linux system within that. So even in Windows you have command prompt. In Mac OS again you have terminal. Even in other Linux GUIs currently like CentOS, Red Hat GUI, then there is Ubuntu GUI. In all of those graphical user interfaces still you have terminal emulators. So normally a Linux system might be a command line interface, but right now you have GUI based Linux operating systems as well. But currently you might have a phone in your hand, you might be watching this video in your phone, or your phone might be on your table, but every one of your family member right now will have a smartphone. Maybe not, but right now any smartphone which is running Android on it has Linux running on it because the Android operating system is built using Linux principles. It's built on Linux. The Android operating system is basically Linux, and you can see 85% of all smartphones are based on Linux. That means there are iPhones, there are Windows operating system phones, there are other operating systems which are again a subset of Android which comes under Linux, and this is one of the reasons. Second reason is your car uses Linux, especially self-driving cars. Not just self-driving cars, there are cars with inbuilt interfaces which have multiple operations. You can basically click on a button and the window wiper will start. So these structures, these algorithms or these microcontroller systems are again running in Linux. Even self-driving cars need Linux to run on them. So why? Because Linux is faster, it's secure, it's reliable than other operating systems. And one more, again, refrigerators also have Linux running in them. Okay, so coming to why Linux is so popular, and I would have told you cars use Linux, your smartphones are on Linux, even your refrigerators use Linux. There are so many other possibilities, your microwave ovens, and there are so many devices which might be using Linux. So now let us look at the supercomputers. So you might be thinking, okay, so they are on Linux, but why not Windows? Why shouldn't I keep Windows and use the Windows operating system to do all that? So here comes the fact. So you can see here, before 2003 or 2004, Unix was dominating the supercomputer market, and even there was some BSD, there was some Mac operating systems, there was some Windows operating systems running on supercomputers. But right now in 2020, the top 500 supercomputers existing in the world are running on Linux operating system. You can see the entire market is right now captured by Linux. So why all supercomputers need Linux is because Linux is lightweight, Linux is fast, Linux is secure, Linux is reliable. So coming to the fact, so if supercomputers are running Linux and they are successful using Linux, why not your PC? Why not your desktop? So basically, it's not a bad practice to use all other operating systems, but coming to the development part, Linux is more preferred by developers. It's not my personal opinion, but Linux is more preferred by developers. But if you're building an application on the .NET framework, obviously you need Windows, or you can emulate it on Linux operating system as well. You can run a Windows virtual machine on Linux. So choosing an operating system is your wish. It's for what kind of a need you need that operating system. But right now we have come to learn Linux. Let us look at more data about this Linux. So right now let's compare between Windows and Linux. So this is one of the main questions asked. What is the difference between Windows and Linux? So this you should understand very well. First, Windows Server, you need to purchase the license. Windows is not free, Windows is not open source. If you're running Windows, so if I'm running Windows currently, my Windows should be licensed. My Windows is licensed. If it is not licensed, that means it's a pirated version of that operating system. Next, Linux is free. It is open source operating system. There are paid operating systems as well in Linux, but so CentOS is free, Ubuntu is free, so you can download them and install them for free. And then not many customization options because like Windows releases few operating systems in few years. Like let's say right now we have Windows 10, maybe in a couple of years or the next year we might get a Windows 11 or 12, but you cannot customize it a lot. But in Linux there are so many different distributions. Even let's say Ubuntu, there are so many different versions in Ubuntu. Then there is CentOS, then there is Fedora. That we'll look at later. We'll look at the various distributions, but this is what is available. There are so many Linux distributions and you can choose one according to your need. And then Windows is vulnerable to viruses and malware threats. A powerful antivirus software is a need. So in Windows, without an antivirus software, if you are trying to download something from the internet, I'm pretty sure you will catch up a malware in your system, because Windows operating system is quite weak in the security aspect. It still has Windows Defender, but still Windows Defender is not equal to full-time dedicated antivirus software which basically watches all the time for malwares it detects and tries to delete it. So that's why Windows is a no-no for downloading things without antivirus. But in Linux, it's more secure than Windows, and the kernel is built as such. Viruses cannot be easily broken. So for an hacker to create a code which will break the Linux system, it takes a lot of practice. The code should be very efficient so that it breaks the Linux system. So these these are the differences between Windows and Linux. And before Windows was MS-DOS, which was again a command line interface, and then there is Linux, again it was a command line interface. But then later on, operating systems got evolved. Windows got its GUI. Right now Linux also has its GUI. There are various types of GUIs. So now let us look at the different Linux distributions you can go for. Coming here, now you can see Debian, you can see Fedora, you can see Ubuntu, you can see CentOS, you can see Red Hat, and you can see SUSE. So there are still a lot of Linux distributions, but I'm just putting up some popular distributions here: Debian, Fedora, Ubuntu, and all. So CentOS is the operating system which we are going to use throughout this Linux course. So we'll not be using any other operating systems. We'll be using CentOS. CentOS is basically the community version of the Red Hat Enterprise Linux, and CentOS has all the features of any other Linux distribution. There is also Kali Linux. There is so many varieties. There is so many distributions in Linux. So you will have to go ahead and check for what exact purpose is this particular distribution better for, and choose your Linux distribution accordingly. But most probably, except the package managers, the commands, the basic Linux commands, the basic Unix commands are going to be the same in every single Linux distribution, so that it's pretty easy to move from one distribution to another. So basically, if I'm currently working on CentOS, I can easily adapt to Ubuntu. So it's like that. So basics of shell. Now let's get into it. So first, we'll be looking at the Linux architecture. So Linux architecture, in the sense, it is not an architecture which is built using hardware. So the hardware part is what you mean by the laptop's hardware or the CPU. So that is the middle part over here, hardware. So hardware just cannot contact with the users directly. So let's say if you just have a motherboard laying on your table, you cannot communicate with it. A motherboard or a microprocessor or anything, a complete setup is there, and you cannot communicate with it, because there is no common language between you and that CPU. So to enable that, there comes kernel, which is the middleman, which basically contacts the hardware for us. So we are the users. We try to utilize few utilities or few applications. So let's consider the application is a calculator. So the calculator, as using the calculator, you want to do arithmetic operations. So now let's say this is the calculator. You are trying to use that application. So now the calculator will basically, this is the application. So there are some commands within the Linux, and those commands are executed on an entity called the shell. So we'll see what is shell, but right now let's consider the architecture. So you have the applications and you have this shell after that. Shell basically executes your commands for you. It will basically communicate with the kernel for you. So as an end user, you see the shell, you type in a command, or you type in something, or you just click on an application. The first instruction will be given to the shell. So the shell gets it. So let's say you want to copy a file, so you use the copy command. So shell knows that you're using a copy command and you're trying to copy a file to another file. So now the shell instructs the kernel. Basically, it interprets the command and it instructs the kernel to do this particular operation. So kernel will understand what exactly is the operation, and it will push that to the hardware, which in a language which the hardware can understand. So an assembly level language or something like that, or a microcontroller language. So it sends it to the hardware. So the hardware will do the operations for you, send it back to the shell, where you can view that. So as a user, you just know you've typed in the command, but you do not know what happens inside and what comes back. So you type in a copy command and you get the results in a fraction of a second, and you don't see what exactly happens behind. So you only see the monitor where you type in the command. You are typing the command on the shell, which is an interpreter for the kernel. So the kernel gets the command and knows what to do, and it does those operations with the help of hardware, and then sends it back to the kernel, and which is visible on your shell, which you can see and understand that the operation has successfully happened, or if there is an error, you can see the error too. So this is the Linux architecture. So moving on, we'll first have to understand what is shell. So a shell interprets the commands you have entered using a keyboard and sends it to the operating system to perform them. So as we've discussed the Linux architecture, You have the shell and then you have the kernel. So both these entities, shell and kernel, are programs which are running on the operating system. The operating system is what making the shell and kernel possible. So kernel is trying to communicate with the hardware. Shell is the interface between the kernel and the user. So now what shell does is it interprets the commands which as an user you give into the system using the keyboard or the mouse. So shell interprets that, it understands what you're trying to say, and it translates it and sends it to the operating system in the sense the kernel. So it sends it to the kernel now understands what exactly should be happened. It uses the hardware help to complete those operations, and once it is done it sends it back to the shell so that you can view it on your monitor. So the basic explanation of shell is this. You need to understand this, only then you can go ahead with your Linux training. So we've understood what exactly is shell. Moving ahead, so nowadays there is a lot of graphical user interface based Linux systems. So even CentOS is a graphical user interface based system. There is also a CentOS server which is a command line interface, but there is also a graphical user interface. So like CentOS, there is Ubuntu, there is Red Hat, there is Debian, and there is Kali Linux. There is a lot of Linux distributions which have GUIs. So in a graphical operating system, how can you basically communicate with the kernel with the use of a shell? So to emulate the purpose of a server, to emulate the purpose of the command line interface, all the GUI based Linux distributions have a terminal within them. A terminal is basically an emulator or a duplicate of a command line interface. So if you click on the terminal, I think most of you would have seen this at least once. If you open the terminal in your GUI based Linux system, you will see a terminal like this. So there you will have your username at localhost or any name, any of your system's name can be given here, and then you have this dollar symbol, and here you will have to enter your commands. So you can see I have entered the command called pwd, which means present working directory. This shows the present working directory, and currently the directory is /home/Intellipaat, so it's in the directory Intellipaat. So that's what it's showing over here. So this is the emulated version of a command line interface. So you can see here a terminal which we see in a GUI server emulates a command line interface Linux server. Terminal emulators are more commonly used now due to GUI operating systems like Mac or Windows or Ubuntu. So even in Windows we have a command prompt, even in Mac we have a terminal, even in Ubuntu or Cent we have a terminal which emulates or duplicates the purpose of a command line interface server. So now coming to top shells, we saw what is a shell and how does a emulator of a shell looks like in a GUI based system. Now we'll be looking at the top shells in Linux. So there is not just one Linux. As I told you, Linux is an open source system. So obviously there are a lot of contributors who creates different types of shells. So the most common, so basically a default shell you can say is bash. BASH, that is bash. The elaboration of bash is born again shell, is a default shell in a lot of Linux distributions. So born again shell is the default one even in CentOS and even in your Ubuntu. In a lot of different Linux distributions, bash is the default one. You can further install other shells also, it is your wish. And then there is zsh, which is basically Z shell, and it is similar to bash or an extended version of it. So basically, as I told you, they take the Linux operating system and create another Linux operating system which has better features. So like that, they took bash and made it better, or added few features like sharing your command history across multiple terminals. So let's say there are 4 different users using the same Linux operating system in different usernames. So you can share your command history to another user. So this is one of the features. There are so many useful features in Z shell. This is one of the useful features in Z shell. So that's what I wanted to share with you. So going ahead, there is fish, friendly and interactive shell. So it is again an extended version of the common shell, which is bash. So it has great features like auto completion of commands. So fish is an amazing shell. So fish has this ability to auto complete your command. So let's say you're typing in grep and your command is going on. So you do not want to type all of that. So if there is a command grep, if you just type gr and hit tab, you will get it auto completed. So it is like a IntelliSense. So it is like an IDE with IntelliSense. So you can use Fish for that. And then TCSH, Tenex C shell, is an extended version of C shell. So there is another shell, basically CSH or the C shell. Basically, the C shell is written mostly on the C programming language. That is why it is called as C shell. And TCSH is again an extended version of the C shell. They've taken C shell and added more capabilities to it. So the plus of TCSH, it is a scripting language because it will be similar for the users who already have experience in C programming. So that's the benefit of TCSH. If you already have a good experience with C programming, if you know how to write code in C programming, so then you will find shell scripting pretty easy in TCSH because it might have the same method of writing. So that's what they're telling over here. There are still so many shells. You can just do a simple Google search and get to know about more multiple shells, but these are the top shells and these are the most popular shells, so that's why I'm showing them here. So going ahead, so this is the command which I executed in the previous window which I showed you while showing the GUI based terminals. So a simple command to interact with the shell. This command below provides the present working directory. So I wanted to show you an example of how you interact with the shell. So basically, if you type in pwd and you are interacting with the shell, when you hit enter, the shell understands that you are entering in a command. First, it validates the command whether this particular command is valid in this Linux distribution. Pwd is a valid command. Then it further pushes it into kernel. Kernel gets it in and basically executes the command with the help of the hardware provided, and then it gives back the result to the shell, and shell displays it to you so that you can view it. So this is one of the examples which I wanted to show you. We'll be looking at the basics of the kernel. Okay, so first, a Linux kernel is a Unix-like operating system kernel. So again, as Linux is a Unix-like operating system, obviously the kernel of Linux will be a Unix-like kernel. So it is a computer program which is the core interface which connects the hardware components to the software processes. So the software processes which you are trying to establish or trying to interpret is basically you are typing in the command on the shell and hitting enter. So you will know this part. Basically you will know the application part where you are typing in the command and then you do not know what happens in the back. It just you get the result. So what happens is whenever you type in a command, you have the kernel in the middle. A kernel is basically a very huge program. It's a very huge program. Right now, I think it's standing up at 2 million lines of code. So it is a very complicated program. And so a kernel, as it's complicated, it is also that helpful. So a kernel is the main interconnection between the software application or the software processes and the hardware components. So let's say if you're trying to find out how much RAM your system is currently using. So you cannot directly go and check the RAM in your system. You need a process running in the background which basically connects to the hardware components and checks how much RAM is being used and sends that information back to you. So that is what the kernel does. So kernel does all kinds of operations that we'll see now. So the top operations performed by a kernel. First, resource management, and then memory management, and then device management, and finally system calls. Okay, now let us get a brief about each of those operations. First, resource management. So kernel decides which process gets a resource for an operation. So let's say you are running multiple processes parallelly. Say in that multiple processes, two processes need the same resource for an operation. So right now the kernel will decide which operation should use that resource first, or which should use it second, because it should not end up in a deadlock situation. So to avoid that, kernel performs an operation which basically chooses which exactly needs the resource right now, or it may delay the process of execution. So it might give it to a process which takes lesser time first, and then it gives it to a process which takes a longer time. So the resource management, there are varieties, but this is one of the main operations which the kernel does. Second one is memory management. Memory management is very important for any server, for any computer. Even in your Windows system, you have 1 TB of space, and even then memory management is very important because memory management is taken care by your system, your operating system Windows, and it takes care of it well. So like that, kernel takes care of memory management as well. Kernel has complete access to the system memory and must efficiently manage it and allow memory access to process. So why do you need memory exactly? Is memory is not for storing content. Memory is to run processes efficiently and effectively. So the kernel should know how much memory should be allocated to each processes so that your system is not completely taken away of free memory. So let's say you have 100 MB of memory and there are 10 processes. Your kernel should decide how much memory does each process deserve to use. So it should provide that efficiently. And then device management. So device management, it's pretty common in every single operating system. So basically, if you're using a Windows system, if you just enter a pen drive, you'll be seeing that in your My Computer or this PC software. So like that, device management is also taken care by kernel. So if we connect devices as a printer or a pen drive, so the kernel will detect it and the system will establish connections with the peripherals. So if I connect in a pen drive, so this particular system, my operating system, should detect whether I've connected a pen drive or not. If it does not detect, then there is no use of a USB port in your computer. So the kernel will detect it, and there is a separate directory in kernel which is known as /dev dev. So that particular directory is specially maintained for device management. So any device entering into this particular Linux operating system or any Linux operating system will have a separate directory for them in the so if I enter a pen drive, that pen drive will have a separate directory within that /dev directory. So Linux kernel also takes care of device management. And finally, system calls. System calls, this is one of the important concepts, and this is an interface between a process and the operating system. When the process does not have permissions to access a resource, a system call provides it without the process accessing the resource directly. So basically, let's say you're running a process, but you've not given the process enough permissions to use a particular resource. So you can use system calls for that process. You can embed system calls in your shell script or in your code. So that when that particular system call is used, your process will be given access to that resource indirectly using system calls. So that is the purpose of system calls itself, to not stop the process from running. It does not interrupt your execution. It helps your execution to complete as fast as possible. For that, you can use system calls, and also you can use system calls to basically do more operations on the operating system level. So let's say you want to abort a particular process immediately. You can use a system call for that. So there are various system calls. These are the 4 important operations performed by a kernel. So we'll be saying this later in this course. So you'll have to just assume that kernel is you don't need to assume actually, you'll have to understand that kernel is the main component of any Linux distribution, and kernel manages all of the top operations of a Linux distribution. So going ahead, so right now we've completed the part that is basics of kernel. So meet you in the next session where we'll be doing a hands-on for installing operating system CentOS on the VirtualBox. So thank you.
Just a quick info, guys. Intellipaat provides Linux administration online training mentored by industry experts, the course link of which is given in the description below.